Next is talking about non-uniform bars. So the circular bar, this problem is a little bit complicated, so I will use numerical method. So I used Wolfram Alpha to solve this problem. So it is just give you an impression about how can you deal with the variable cross-sectional problems. For this circular bar, the radius is given by 0.3 sine z plus 0.5, and there is a compressive load P equals to 100 Newton. Estimate the minimum and maximum absolute reading. Absolute reading means that no matter whether it is positive or negative, we take the absolute value. And the total deformation of the bar. So in order to solve this problem, we observe that the maximum absolute local strain occurs at the location of minimum cross-sectional area. Recall that Rz equals to 0.3 sine z plus 0.5. The cross-section is a circular region. Therefore, we conclude that the minimum cross-sectional area occurs at the minimum radius. In order to make the radius minimized, we take sine z equals to minus 1. Therefore, R equals to 0.2. Consequently, we can find the minimum cross-sectional area. Next, we can use the stress equation, which is applied load divided by the area, to calculate the maximum stress in the structure, which is compressive 7.96 million-pascal. Therefore, the maximum absolute strain is by using the maximum stress divided by the Young's modulus, then take the absolute value, then you will get the answer, which is 7.96 times 10 to the power minus 4. By similar manner, in order to calculate the minimum stress, we will find the maximum cross-sectional area. Recall that Rz equals to 0.3 sine z plus 0.5. Therefore, if we take sine z equals to 1, then the maximum radius will be 0.8. Therefore, the maximum cross-sectional area will become pi times 0.8 squared equals to 0.64 pi cm squared. Notice that the minimum stress, still it is compressive, it is negative, but we can observe there is a change in cross-sectional area, right? So the minimum stress is compressive 0.497 million-pascal. Consequently, the minimum absolute strain is given by the stress divided by the Young's modulus, and then we take the absolute value. Then the result will become 4.97 times 10 to the power minus 5. Next, we want to find the total deformation of this circular bar with the variable cross-sectional area. If you still remember, delta equals to the integral from 0 to L P dz E A z, where P, E are both known. For A z, we know that it is a function with dependent variable z. Therefore, we can write the cross-sectional area in terms of z, so area is pi r squared, and R is given by this formula. Therefore, A z can be written in this form. After we identify A z and we know P and E, then we just take them out and substitute A z into the expression. After that, we will eliminate the units. We make everything into the SI units in order to get rid of being confused. Eventually, we will get an integral like this. However, since this piece of integral is very difficult to be solved, the only way you can do it is to use some online widgets such as Wolfram Alpha. So I used Wolfram Alpha to solve it, and eventually the result is minus 0.0189 millimeters. That means the deformation is negative and the bar is become shortened. It is shortened by the external load by 0.0189 millimeters. Finally, check that the epsilon, the average strain, is bounded by the minimum and maximum value. That indicates that our answer is reasonable.